What's up, friends? Today we are starting another battery build, except this time it's going to be different than any that we've done in the past. I've actually just finished building another big pack, and I'll link that video up in the iCard. That is a 12S8P4A flux build, but this one is going to be completely different. This pack is going to be a brick style pack using these dividers that I designed and these Molicell P42As. It will be in a 12S7P configuration, and we'll be going in a custom enclosure that I designed, but we're not going to get into that in this video. So stay tuned to see how to build a brick pack in its very interesting configuration and how it might be useful to you. Okay, before we get into this battery build, I just need to do a little bit of due diligence and warn you guys that building batteries is dangerous. If you mess up while you're building a battery by puncturing a cell, spot welding it wrong, soldering it too hotly, overcharging it, over discharging it, or in general mishandling the cells, you could end up with a fire on your hands or with a pack that is not safe to use. So please, if you are concerned about building a battery pack and you don't think you're able to do it, I would resort to an expert battery builder, and I've got a list of those listed in the description under the forum link. Now, even though I do give this warning at the beginning of my videos, I'm not responsible for what you do with your batteries, but again, it doesn't mean you have to be afraid, it just means you have to respect them and know what to do in order to do it properly, and I do my best to tell you guys how to do that. Now, before we start this pack, let's go through the materials and the steps of what we're going to do. Alright, so the reason I wanted to go through the materials for this pack is because they're a little bit different than the ones you might be used to seeing in my other videos. There are some things that are similar, but not quite. So the first thing we've got, which you will have seen before, is Molicell P42As. These are extremely powerful batteries, and I get them from 18650 Battery Store, and they've been a super reliable supplier for me thus far. The next thing we've got is our BMS. This is an LLT Smart BMS, and I've used this in quite a few builds in the past. I'm not sure I've shown you guys one besides the one in the flux build, but pretty much it's a smart BMS that lets you connect to your phone and see the battery voltages, which is super useful. The next thing we've got is our nickel to actually weld the pack together. This roll I got a long time ago in preparation for building this pack. This pack has been a long time coming, and I've finally found time to do it. So in here we've got some 25mm wide by 0.2mm thick nickel that we're going to be using for this entire pack. And in order to construct this pack, we've got some other special supplies, which are these dividers that I designed myself, and these standoffs and other dividers. So using these dividers, I will be able to skip the part where you put fish paper between the parallel groups, and I will also be able to do both the series and parallel connections of the cells using one strip of nickel. And you guys will understand what I mean once we get into the actual welding and assembly of the pack. It's not as confusing as you might think, but it's a really great, easy method to do for a brick pack like this. Of course, you could use fish paper between the cells and forego these more complex dividers and save a little bit of weight, but this makes it really easy for me, and it's going to make this pack build super quick in the amount of time that I actually spend off camera building. I don't think there's too much else to mention here. We've got our fish paper rings already installed on the cells. I went ahead and did that before. There's no really point in having me show the installation of these rings again, but if you want to see me install rings, go watch one of my other videos that I've got linked in the iCard, and you can see me put pieces of adhesive onto cells. Anyways, let's move on to the steps. Alright, so the steps for this pack are going to be a little bit different than some of the other ones I've done, but they follow the same general progression. So first, we are going to assemble the battery, which actually is quite different. We're not going to be gluing any of these cells. We're not going to be wrapping them in fish paper. We already put the fish paper rings on. So the next step is just to insert them all into this structure. So we're going to start by assembling the battery, putting all the cells in here. We'll screw the structure together, make sure everything's aligned well, And then after that, we will be able to move straight onto welding. And we'll go ahead and weld almost all of the parallel groups together. And then we will solder on the discharge leads to the positive and negative, weld those on, and then after that we'll go ahead and run all the balance wires, plug them into the BMS, and that'll pretty much be it. I don't know how long this video is going to end up being, but this pack assembly should be super quick for me. I'm definitely looking forward to that because batteries usually take quite a long time. Let's get into the assembly. Alright, so for cutting the nickel, I have these two pieces of paper, and these two pieces of paper are very important because they're the exact dimensions of how long my nickel strips need to be. Now, I made these pieces of paper from the dimensions that I have in my CAD model, and I created this 3D model mostly so I could design the cell holders, and then I was able to get the lengths of the nickel from there. And like I corrected in my editing, this is 30mm wide nickel, not 25, so that definitely helps with the fact that I have these extra wide spacers versus just fish paper. So got our nickel here, quite a large heavy roll of it, and we're going to start unrolling this and we'll start cutting it down. I'm just going to cut one of the angled ones and one of the straight ones, and then I'll skip all the other cutting because it's not that interesting. So let's get into it. Alright, so I've not test fit all of these cells in here yet, but I've test fit a couple of them, and the way I design these is so that they hold pretty tightly onto the cell itself. So it might deform the outer sleeve of the cell, the plastic part, a little bit when I press them in, but that shouldn't really be too big of a deal, and I'm not planning on taking these cells out, so we should be okay. Now my goal here is to make the cell level with the bottom part, leaving it just enough out for it to engage on both sides. So go ahead and test fit with just a single one. You'll see that it fits pretty much perfectly so that the cap aligns to be spot welded. And you can see the edge has a little bit of So I recorded this video like months ago, and I have no clue what this clip was supposed to say, but it has no audio. So I wish I could tell you guys that this 3D printed holder system is the perfect solution to making fast packs, but on the printer that I printed this on with that filament, it is not. I had a very difficult time fitting all these in, where half of them are super loose and half are super tight. Because of this, I think you'll see here that I have a tough time getting this down. And, you know, I really don't know what the exact solution is to this. Either it'd be better tolerancing on my prints, maybe a different shape of the holes as you travel, as the cell gets inserted in. But man, was this frustrating. I can't even explain to you. It took me a long time and it really pissed me off. Nevertheless, I ended up getting it on there, and to be honest, once it was on fully, it's pretty satisfying. I think there is a future for this kind of pack design. I think it just needs some improvement, and if I make another pack like this, I'll definitely make that improvement. So yeah, I know someone else in my battery builders group has done something similar, so maybe I'll take some tips from him and try it again someday. But in any case, this method ended up being successful for this particular pack, and it's been running for almost 900 miles in my board. So yeah, on to the next clip. Alright y'all, I have no idea what I was doing when I recorded this, but we got another no audio clip. So let me explain what we're doing here. So I've got a bunch of the cells taped off with blue tape on one side of the pack, and that's because it's time to start welding. I'm going to be welding the top side of the pack, as you can see here, and on this side we'll be connecting all of the cells together in parallel as well as series. So in order to protect the cells from any shorts on the underside, we're just going to tape them off and make sure that that can't happen. So let's go ahead and get started on the welding. On this particular pack, I chose to cut the corners of the nickel while I was doing each of the strips. So here we are rounding the corners of the nickel, and now we've got the nickel laid out on the first spot to weld, and I've got some magnets holding it down on the positive and negative sides. And now there's one thing to remember here. As we start connecting these cells together, we're going to have a short circuit path from the negative to the positive of the next cell over, which is partly why we put the blue tape on the bottom. This will be more important when we start welding the second side, but for this first side, we're just going to go ahead and start. Alright, so we just finished welding the bottom of this pack, and now I have cut all of the nickel strips to, or I've rounded all the nickel strips to weld onto the top. And now I just wanted to give you a warning. The pack is quite dangerous. If you know what, let me switch to different camera view here. If you were to short across a set of cells that is connected on the bottom, that would be very bad. So I'm going to be very careful while I'm doing this, but if you are building a pack like this, I would highly recommend taking some blue tape and just putting it over the cells that you're not welding, and that will make it a lot easier for you, but for camera and because I'm going to be very careful, I'm going to leave the tape off. But I thought that would be a helpful suggestion for you guys if you're welding something like this, where you could drop it on the pack and short out a whole bunch of cells. So just be careful. Let's get on welding the top, and then we will get on to soldering the positive and negative leads. All right, so right here we have our completed set of spot welding, except for the positive and negative leads. Now, the reason I left these till last is because we need to solder to these first. For a gigantic battery like this, where I'm going to be pulling a lot of current, we want to solder to, well, you don't have to, but I'm going to solder to 3 places along this length of nickel in order to get the best discharge path and spread out the current along all of the cells. Now, it's also important to solder this before you spot weld it to the pack, because if you spot weld it to the pack, it turns into a gigantic heat sink and it's going to make it impossible to solder and you might damage your cells. So solder onto the nickel first and then spot weld the nickel to the pack. So we're going to go ahead and solder the positive and negative, and then we'll weld them onto the pack. All right, so we're about to solder onto both the nickel and the cable. And basically what I did here is I drew out my 3 points that I want to solder to on my cable with Sharpie, and then I stripped them off carefully using a razor blade. And now we're going to use some flux on all these spots and solder them together, and we'll have a nice distributed current discharge path. Both the negative and positive are now soldered, and I was able to get a much nicer finish on the negative set. I changed up my technique a little bit, but I still hate soldering these. So I might need to get another iron that is a little more powerful if I'm going to do things on gigantic pieces of nickel like this. And it's especially bad for the center one because the heat dissipates so quickly out from the center point. So now it's time to spot weld these on, and that will be our completed spot welding setup on the battery. All right, so I honestly have no idea what the last clip was. I'm not gonna lie, it's been a little bit since I've fully worked on this, but right now we're going to be working on the BMS wiring. So we've got the whole pack put together, we got all the nickel on there. I've cut some rubber padding that it will be sitting on inside the enclosure, and now it's time to run all the balance wires. So basically what we're going to be doing is, this is actually the bottom of the pack. You probably we're not able to tell that just by looking at it, but this is the bottom. So we're going to be wiring that up first. And basically what we're going to be doing is we're going to be putting the BMS on the far side back here, and we're going to be running the balance wires all the way around to their respective locations, just because that's the best way that the wiring routes worked out. So I'm probably gonna have to extend a couple of these wires, but we'll just make it work. So we'll get started on this. First I'm going to put some fish paper down, and then I'm going to cut all the balance wires to the right size, tape them down temporarily, and then we'll go ahead and solder it. So I'm probably just going to cut from clip to clip, and yeah, hopefully this is interesting to you. Alright, so we're going to be doing the balance wires. I have nicely glued down this whole lane of balance wires. Make sure you unplug your balance wires before you start soldering anything into place, because that will avoid any kinds of issues that you might be worried about later. So now the wiring on this is going to be quite interesting because of the way I have this laid out. We have cell number 1, or negative, starts here. So you're going to start with your black wire, and you're going to count up from there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. However, that does present an issue because they're on opposite sides. So our negative wire is going to go there first on the right, and then our number 2 wire is going to have to make the journey over here. Now, crossing balance wires like this is not always what you want. So what we're going to do is I'm going to poke a little hole in the fish paper and run this behind, and that will allow it to just rest in there, and then we'll bring it up and over this edge onto the top of the cell, and we're going to do that all the way down the whole way. Now the reason I can do this is because I know that this edge of the battery structure is not going to be touching the enclosure. There's not going to be any crazy vibration there, so running this balance wire behind this fish paper is fine, and it will nicely separate it from this row of balance wires. So we're going to speed through that process real quick, or I might not even show it, but I'll see you guys in a second. It is now time to solder on the balance leads. You can see along the top I've taped down each of the balance leads into its spot where it should be. And now we're just going to go along and solder them all to their pads. I highly recommend having the balance lead connector unplugged from the BMS during this process, as you don't want to accidentally solder one in the wrong spot. I always check mine before I plug it into the BMS, and this time is no different. So this will end off all of the balance lead soldering. Alright, so I've got all my balance wires done, and now it is time to do the BMS leads. So we're going to need to solder a couple things here, one of those being B-, which will connect to the negative lead of the pack. After that, I will be soldering an additional lead onto the negative of the pack, because I will be running some headlights and I need negative to attach to the buck converters that power them. So first we got our B minus. Okay, I did misspeak. The additional lead is going to the negative, not to the B minus. And I consulted some documentation and I decided that 16 gauge is plenty, so I'm going to go ahead and twist that together with the B minus wire and then solder it onto the pack, onto this pre-tin spot that I prepared before finishing the pack. Alright, now to the C minus port, we will be attaching 2 leads. One will be to our actual C minus, which will go to the charge negative on our charge connector. And that will go through this fuse because every safe pack has a fused charge port. Now you can technically put this on the negative or the positive. I might change my mind and put this on the positive because I typically like that better. But we will definitely need to attach the discharge negative onto here for my headlights, so we'll go ahead and do that, and I'll make up my mind if I want to put this on the minus or on the positive. I probably should have done this at the beginning of this part, but let's go over the diagram to alleviate any confusion. On the left side here you can see the charge port along with the positive lead with the 30 amp fuse on it. Additionally, you can see 2 other positive leads, one for the ESC positive and one for headlight positive. On the negative side, the C minus also provides the discharge out of the BMS. That is what we want to switch in order to turn on and off the headlights, so we have an additional headlight negative there. On the other side of the BMS, going to the B minus, we are connected directly to the battery negative, and then the discharge negative comes directly out of the battery into the ESC. If your setup needs a loop key, you can see here where you would place that. Alright, so we've got everything soldered up now. Onto the C minus we have our headlight discharge as well as our charge negative. And we've got our 3 positive wires, and that's pretty much all we need to do now. So I'm going to solder on the charge port connector, and then we will be good to go to give this bad boy its first charge. Recently I've switched to making all of my charge ports able to be disconnected. So we've got an XT30 here that will serve as the intermediary connector between the battery and the charge port. On this build I use a GX16-2 for the charge port, but I eventually switched it to a Weipu SF12, which is a much higher quality connector. Alright, so I've pretty much finished the pack off. I connected the rest of the wires. I've got my discharge connector for my headlights. I've got my fused charge port. It's in fact actually charging right now. We've got our discharge leads, which I still need to connect to a XT90, but that'll be integrated into the enclosure. And yeah, that's pretty much it. All the balance leads are done, and the only thing left to do is put some fish paper on top or Captain tape to cover up these exposed contacts. Wrap some fiber tape around it for reinforcement, tape the BMS on, and just clean it up in general. So we'll go ahead and do all that, and then I'll take some nice B-roll for you guys and film an outro, and we'll be done with this battery. Forgot to record an outro, so here's some fun facts instead. I built this battery back in March of 2022 and it's been running just fine since then. It has about 900 miles on it to date and everything has been holding up as I would expect. There are definitely some improvements I would make to this design if I did a version 2, but for my purposes, this has been great so far. Thanks so much for watching, and hopefully you guys enjoyed it. Leave a like if you did, and stay safe, keep on riding, and peace out.